A satellite dish is shaped like a paraboloid of revolution. This means that it can be formed by rotating a parabola around its axis of symmetry. So you can see it right here. There's a satellite dish, right? It's three-dimensional. So over here I have a flat parabola. If you took this parabola and you rotated it this way and made a three-dimensional bowl out of it, you would have a satellite dish. So a satellite dish, the curvature in here is parabolic curvature. You'll learn, especially as you go into higher calculus, but even now is a good time to start learning that not all curvature is the same. When something curves, the rate at which it curves is very important, right? I could curve and come around in a circle, but a parabola will not do that. Right, a parabola will go out and up and it doesn't curve so fast as to come back onto itself. It's a different rate of curving. You can imagine if you're driving your car and you suddenly turn the wheel and you just hold it steady, right? And you're curving. You could hold the wheel so that you spiral out further. You could curve the wheel really tight so you spiral in, or you could curve it so you go in a perfect circle. You're just holding the wheel at a certain rate of bending. Well, parabola bending is really, really valuable. We saw earlier in the course that parabola equations are how, like, anytime you throw a baseball or hit a golf ball or a rocket, well, not a rocket, not something with its own motor, but a projectile is launched. Anything flying through the air that doesn't have its own engine. If it has its own engine, it can do whatever curvature it wants. But if it's just flying through the air, only under the influence of gravity and whatever initial velocity it was given, like throwing a football or anything like that, it's going to go in parabolic curvature. So parabola equations were used back then. We didn't call them parabola. We just called them x-squared equations. But any object flying through the air, any artillery that's launched in the military, those are always y equals x squared kind of equations. And not only that, we now see that satellite dishes are parabolic curvature. Why? Because the bending inside this satellite dish, the curvature is just right to bounce everything right to the focus point. What do I mean? Well, there's every ray that comes in is going to bounce and go straight to here, this focus point. Every ray. The curvature, boing, it'll bounce everything right to that receiver. That's located at the focus. That's why they call it the focus. All the rays, all the radio waves or TV signals or video signals, whatever's coming from the satellites that bounce and hit that parabolic shaped dish, that the surface is curved to aim everything at the focus point. It's focused on the focus point. That's why it's called that. So that's where you put the receiver. So you see how they place a receiver right there. It'll bounce, all the incoming rays will bounce right to that receiver. So then they can, bring it down here through wires and send it signal on. So that's how they work. Headlights, flashlights work the same way. They just put a lamp right here in your headlights. They put a lamp right here, and the lamp shines backwards, and it bounces. If you look back at your headlights and you go back to your car today, you'll notice that the curvature in there, that rounded surface, the silver, shiny, mirrored surface, is parabolic, which means it bounces, it works the opposite of a satellite dish. The lamp is here, and it bounces everything back straight out for your headlights. So we use parabolas a lot in life. So on this one, they're giving us some specific information, and they're telling us, okay, got a parabola. I put it over here on an axis system. Now, we just as well could have made the parabola go to the right as we could have gone up. It's not on any real axis system. In fact, in real life here, it looks like if you put the axis system right about there, it looks like the thing's kind of tilted at an angle. Well, whatever. Remember, math is made up. We make it up however we want to describe things that are real. So the satellite dish is real, but I'm going to use math and put a parabola on an axis system that's made up that fits the reality of the real life parabola. So I'm going to make it easy for us. I'm going to put it right at the center, right at the origin, aiming straight up. That'll just make our equations easier, and that'll still represent the real life parabola. That's how math works. Specifically, it's made up to describe things that are real. Now, if it's going up like that, let me get rid of this. If it's going up like that, they're telling us that it's 108 feet across at its opening. So this must be 108 feet this way and that way. 108 feet across at its opening. And it's 9 feet deep at the center. So that means from there to there, whoops, is 9 feet. It's 9 feet deep at the center. Then they're saying, where should the receiver be placed? Well, the receiver is going to be at the focus point, which is beyond the depth. So the receiver will be somewhere out here. Here's the receiver, and that is at the focus point. So the question is, how far to that focus point? Well, we call the distance from the center to the focus point A. That's what in the parabola equations, that's our A. So now, speaking of that, remember the 4 parabola equations. Let's do those real quick. We have 4 of these. Let me just squeeze them in here. We can have the parabola going up, down, right, or left. It can go up, down, right, or left. If it's going up, that's x squared is positive 4ay. This is what you want to have in your notes. If it's going down, it's x squared is negative 4ay. If it's going to the right, it's not that. It's y squared is positive 4ax. If it's going to the left, it's y squared is minus 4ax. Okay, up, down, right, or left. So now the question is, let's try to find the equation. That's the first thing they want, the equation of our parabola. So which one of those 4 directions? We're going up, so this is the very first one. So x squared is positive 4ay. So our equation is x squared is positive 4ay. We're centered at the origin, so we don't need to mess around with any numbers next to x or y. It's 0, 0. All we need is a. We already know a. Well, actually, we don't know a, do we? We don't know what a is. Yeah, my mistake. We don't know what a, but we know a point right over here. We know this point. We know the coordinates of that point. How do we know? Well, it's 108 all the way across. So we can actually figure out how far from there to there, can't we? It's 108 divided by 2 must be 54. I just took 108 and I divided by 2 to get 54. So this point must be over 54 up 9. See the 9 there? 9 is how far up? So over 54 up 9. So that's an XY point, isn't it? That's X and Y. So that means it's a point on the parabola, so it's got to make the equation true. So I can plug in there, so I get 54 squared. 54 squared, whoops, kind of messing that up, aren't I? 54 squared equals 4 times A, and what's Y? 9. So use your calculator, 54 squared, I'm getting 2916 equals, and 4 times 9, 36A. How do you finish solving for A there? Divide by 36. Those cancel. And I'm getting 81. So A must be 81. So now we have the equation. Let me grab the equation, bringing it over here. It must be A squared is 4AY. And now we know A is 81. So plug in 81. So X squared is 324Y. And there we go. We got the equation. Sure enough, it matches that one. Okay, so we got the equation now. That's their first question. There's the equation for that parabola. Now we want to use that to answer the question they put here. How far above the vertex should the receiver be placed? That's what engineers would want to know as they build these things, as they build real-life parabolas, satellite dishes. They'd want to know, how far is this? How far from there to there? How far out should we put the receiver from the base? Well, we've already got that right here, don't we? It's already done. Nope, whoop, let me take that back. It's not that. It is the A. The A is how far out to the receiver, because the focus receiver is this right here. So the A, and we already found A right here, 81. So the answer is 81 feet. As they said, 81 feet. We already found A down here. A is how far to the focus point. So there we go.